In this video, we are going to take a look at the core feature that the Spring AI module offers. But before we dive in, let's quickly talk about what Spring AI actually is. Spring AI is a framework that lets developers easily integrate AI models like ChatGPT or Gemini into their Spring Boot application. It also provides abstraction layer over this provider so you can switch between different AI models without changing your core code. In this demo, we will working with Azure OpenAI, which offer major models for chat completion, image generation, and audio transcription. Specifically, we are using GPT-o4 Mini, Flux 1.1 Pro for image generation, text embedding ADA002 for embedding, and Whisper for audio transcription. This deployment name can be anything you choose. I just kept them based on the model name for clarity. So first let's look at the build.gradle file, which contains all the dependency we need. This dependency Azure OpenAI is used to communicate with Azure OpenAI models. These two dependencies, vector store and vector store pgvector, is used to implement RAG functionality, which we will look at later in this video. The rest are standard dependencies like Lombok for code generation and other Spring utilities. Next, we have application.yaml file, which contains the configuration for our application. Here, we are providing API key and endpoint through environment variable. We also specifying which deployment to use for image generation, audio transcription, and chat completion. Now let's start both our front-end server and back-end server. Since this video is mainly about Spring AI, I won't go into much details about front-end. Let's move into image generation first. You can use audio input to generate text. We will look at that a bit later. For now, I already have prompt, so let's just copy it and paste it here. Let's generate. As you can see, picture is already generated. You can also download it. Now let's see how this works internally. When we click on generate image, the request goes to image controller here, and from there the service layer receives the prompt and use it to generate the image. Inside the service layer, we have an instance of the image model provided by Spring AI. We can use the image model.call method with options in the image prompt to generate the image and then send the result back to the front end. Next, let's talk about audio transcription. When we want to use audio input and get text output, we use audio transcription. So when we start microphone, which use media recorder API in the browser to record your voice. Let's start microphone. Tell me about yourself. Once the recorded is completed, it's sent to audio controller, similar to how image generation works. From there, the service layer takes the recording and generate the transcripts and send it back to the front end. Finally, we append the generated transcript from our current prompt so we can use it to next request. Now before we move further, let's quickly talk about vector stores and embeddings. A vector source stores is Basically, a database that stores text or data as numerical vector, which makes it easy to search and retrieve similar information based on the meaning. And an embedding is that numerical representation of text. It captures the semantic meaning behind words or sentence. Together, the embedding and vector store form the foundation for retrieval augmented generation or RAG, which we will look at the next. So now let's add a PDF to provide some context to our application. When we upload a PDF, the application converts its content into embedding and stores them inside a vectors. Here we are using pgvector, which is an extension of PostgreSQL designed to store and query vector data. So this PDF is contain one problem statement with some solution. So let's ask about it. As you can see, it's properly describe what problem statement is. As you can see from here also. So finally, let's take a look at how everything comes together inside our chat service. This class handles both chat response and PDF upload. We are using dependency injection to bring in three main components: chat client, vector store, and token text splitter. Inside the get chat response method, whenever the user uploads one or more PDF files, we first read those files using page PDF document reader, which extract text page by page. Then we use token text splitter to break the content into smaller manageable chunks. Thus these chunks are converted into embeddings and stored in our vector store, which in this case is backed by pgvector. After processing the files, we build a prompt template. This defines how the model should combine the user query with contextual information retrieved from the vector store. Next, we create a question answer advisor which tells Spring AI to use stored vectors for contextual retrieval before generating the final answer. Finally, we use chat client to send the query. The advisor automatically perform a similarity search on the vector store, retrieve the most relevant context, and then the model generates a response based on that. So overall, this service connect everything from reading the PDFs and storing embedding to generate context-aware response using Spring AI's abstraction layer, and that's how you can easily build a RAG-powered AI assistant with Spring AI and Azure OpenAI. If you watched this far, thanks a lot for watching and peace out.